Chapter 4: An Experiment with Time. Before we start this chapter, it would be good to remind the reader of the purpose of this book, as described in the introduction. We are faced here with phenomena that are difficult to explain. It will take many years before science will have even a rudimentary understanding of mental phenomena. It is common practice in science to try to make a model, undercodes, which describes a certain set of phenomena closely. It may be a rudimentary model at first, which will be refined later as more knowledge of the area becomes available. A successful model for any set of phenomena has to fit these more phenomena in a simple and economical way. The more new tenets are required to build the model, the more cumbersome and more vulnerable it becomes. Knowledge moves in an ever expanding upward spiral, which allows us to see from the higher turns of the spiral our previous knowledge in a broader perspective. Thus, Newton's mechanics have become a special case within Einstein's theory of relativity. So, eventually, will Einstein's theory of relativity become a special case in a science that will account for both physical and mental phenomena? New and more sensitive methods and instruments enable us to do increasingly sophisticated measurements. We can now measure magnetic fields around our heads due to the tiny electric currents in the brain. We can make highly sophisticated measurements that show that whenever there is the slightest change in any system in the body, all other systems are somehow affected. No longer can we view our body as a collection of separate organs thrown into a bag in which a specialist can fix one organ without affecting the others. As is the body, so is the society and the whole planet, the solar system, and indeed the whole cosmos. I hope to show by the time we come to the end of this book that we are part of a highly integrated system in the broadest sense of the word. However, back to our model. In it, we'll try to tie together as many diverse phenomena as possible and fit them into a compact system. The physical, objective phenomena serve as a starting point for this model. Experiment with time. In the previous chapters, we talked about the action of the nervous system, which receives input from the environment and codes it for us in an action rest language. This action is naturally occurring in time, that is, it takes time for any of these events to happen. When we think of time, we think of clock time. Action all around the world is synchronized by clock time, starting with the train schedules, worldwide plane schedules, navigation, astronomy, worldwide telecommunication, etc. These depend completely on accurate timing. The accuracy standards of timekeeping devices have been increasingly rapidly due to the demands for more and more accurate timing for space communication, navigation, astronomy, etc. Rather than use mechanical clocks, we are relying nowadays on atomic clocks. This is not a clock in the usual sense, but a device that uses the very stable oscillation of the cesium atoms as a standard for timekeeping. For grandfather clocks to wristwatches, all these clocks are supposed to chop up for us the 24 hours of the day more or less reliably into hours, minutes, and seconds. Let's call this kind of time objective, since everybody's watches are supposed to cut time into slices of even thickness. However, we know from personal experience that time does not feel as passing evenly under different circumstances. When pursuing some interesting activity, time flies, undercourse. While waiting in the dentist's office, it drags, undercourse. When Einstein was once asked about this psychological time, he replied with a now famous observation: when you spend 2 hours with a nice girl, you think it's only a minute. But when you sit on a hot stove for a minute, you think it's 2 hours. Having thus firmly established the relativity of time, let us see then how this subjective time can be put to some use. We know from sleep studies that during dreaming periods, time dilation occurs. In other words, if, for example, a person is awakened after a very brief period of active dreaming and is asked to describe what happened in his dream, usually a long story will come out, which would have taken a much longer period of objective time to occur. We also know that under hypnosis, time dilation can take place and can easily be noticed. Studies on such mind-affecting drugs as cannabis, LSD, etc. indicate that time distortions occur. Since these materials are not unknown substances to most readers of this book, we may possibly use them as an example. When listening to someone talk while under the influence of some of the mind affecting drugs, the feeling is that the speaker is talking very slowly and that the pauses between words are extremely long. In fact, we are sure that we could easily run once around the block before the next word comes out. There is no change in the pitch of the sound of the words. That is, the words do not sound like tape recorded speech on slow speed. Clearly, what happens is that we somehow have more subjective time and we can observe the act of speech in greater detail. Have our mental processes been speeded up relative to those of the speaker? Or do we simply have more time in which to observe the event? Let's try an experiment that should shed light on this dilemma. When a person has been trained by biofeedback to produce theta waves or can put himself into a deep meditative state and at the same time is able to watch the second hand of a clock in front of him, he will be surprised to find that the second hand has come to a stop. It's rather a startling experience, and the natural reaction to it is, "This is impossible." At that moment, the second hand will accelerate and resume its normal rate. However, if we can get over this reaction and watch with half open eyes the face of the clock while all the time being in a deep meditative state, then we can keep the second hand from moving as long as we wish. The above experiment is naturally limited to people who have specially good control over their states of consciousness. I have designed an experiment that is within easy reach of practically anybody who wants to experience this change in time, or at least in a minor way. It does not require any training or any drugs. The only thing we need is a clock with a second hand or a wristwatch with a fairly large dial and an easily visible second hand. Step 1. Relax. Position the watch in front of you on a table so that it will be easily visible without any effort through half closed eyes. Lean with your elbows on the table if you wish. Step 2. Look at the watch in a relaxed way and follow the second hand. Try to observe and remember the rhythm at which it moves. All this has to be done quite effortlessly. Step 3. This is the crucial step in the experiment. Close your eyes and visualize yourself engaged in your most favorite activity. This visualization has to be as perfect as possible. For instance, if you visualize yourself lying on a beach in the sun, you have to be there, all of you. Don't just think you are there, but feel the warmth of the sun and the texture of the sand. Hear the sound of the waves. Use all your senses. The results will be better if you choose a relaxing activity rather than a hectic one. 4. When you feel that you have stabilized your visualization, slowly open your eyes just a bit. Don't focus on the watch. Just let your gaze fall on the dial as if you are a disinterested observer of this whole affair. If you have followed the instructions properly, you may see the second hand stick in a few places. Slow down and hover for a while. If you are very successful, you'll be able to stop the second hand for quite a while. To some people, this is a shocking experience. The moment one feels shocked, the second hand accelerates and resumes its normal speed. Clearly, there is something very disturbing here. We have described several instances in which time is being somehow manipulated. I'm not saying that we have actually slowed down the movement of the clock. It is still keeping good old objective time. But we did stretch our subjective time so that we are facing a subjective situation that in turn provides an analogy to a well-known objective situation. This was first made clear in the theory of relativity, in which it was shown that two observers moving relative to each other do not agree on the rates at which their respective clocks are running. Let us try to analyze what is common to all the cases. We find that the connecting link is an altered state of consciousness. Some may claim that the last experiment has nothing to do with altered states of consciousness. In fact, some will altogether deny the existence of such a thing as consciousness. Why, then, did the watch slow down or stop altogether for a while? I propose that the observing mind, or the observer for short, the entity that correlates and makes sense of the information submitted to it by the brain, was absent. It went off to the beach and left the hardware, at home, unattended. The hardware, by which I mean the sensory organs and the brain, are processing and producing the information, but the entity that correlates and makes sense of the information has left the body for a while. This is not as frivolous as it may sound. Such a hypothetical AWOL observer could have been noticed on the beach by a so-called sensitive or clairvoyant person under the right conditions. While the observer was busy correlating the information coming to him from the beach, he could not handle the information presented to him by the physical eyes gazing at the watch. From the moment the watch stopped to the moment it started moving again, the observer was out of the body, undercourse. In cases in which the watch has only slowed down, the observer was split, undercourse. He was partially on the beach and partially in the body, handling information at a reduced rate. In following chapters, I intend to discuss how all these strange doings of the observer can take place. For the time being, we shall stay with the results of our experiment and try to make sense of them. In the case of the complete stopping of the watch, the eyes have become an inert camera, projecting to the screen of the brain the last information they have seen before the departure of the observer. And of course, this is analogous to the little mini calculators in use today. The screen displays and holds the last information the operator has punched in. Any alert reader has probably noticed by now an interesting property of this observer. He can flit about to distant places in fractions of a second. He may leave this physical body and be off to a beach thousands of miles away and be back all within 1 or 2 seconds. In the previous chapter, we discussed the behaviors of oscillators and pendulums. Let's recall what happens when a pendulum comes to one of its extreme positions. We found that between the points at which the pendulum has to come to a full stop and the point at which it started on its return trip, there is an area in which causal relationship between time and space breaks down, in which its position smears out on a course, and infinite or nearly infinite velocities are encountered because of the uncertainty principle operating on the quantum scale of things. We know that we cannot accelerate physical objects to the velocity of light, not to speak of infinite velocities. But under the conditions we are discussing, physical matter loses its definiteness. It becomes less solid, of course, thus making it easier for the observer to separate from it. Our bodies, as we know from chapter 1, behave in pendulum-like fashion. It is possible that the observer, having no physical mass, could be flitting back and forth at very high velocities with each up and down movement of the body. And if this is the case, where does it go? A simple diagram will help us to put in order the previously discussed phenomena. Do not be intimidated by the diagrams. The author has full understanding of most people's distaste for mathematics, graphs, etc. However, diagrams communicate better and faster than words. So just bear with it for a while. It will be over quickly. In figure 23, our four-dimensional spacetime is represented by two lines. The vertical direction stands for time, the horizontal direction represents space. Let us remember that the space has three dimensions, but here they are represented by horizontal directions only. Passage of time into the future is shown as movement upward above the horizontal line, while all that happened in the past is shown below it. The crossing point of the horizontal and vertical lines represents our now on the course. It is the starting point for any event. Let's try to make use of this diagram and see how a photon, which is a particle of light, would behave on this diagram. We know that light travels at about 300,000 km per second, so starting from the now point, we mark off on the vertical line our units of time, 1, 2, 3 seconds. On the horizontal line, we mark off the distance traveled by that particle. For the first second line, it has traveled 300,000 kilometers. For the next second, 600,000 kilometers. For the third second, 900,000 kilometers. From the points on the vertical line, which indicate time units, we shall now extend dotted horizontal lines, and from the points on the horizontal line, which indicate units of distance, we shall extend dotted vertical lines. These lines will cross, and through their points of intersection, we shall draw a diagonal line, starting from the now point. We can extend the diagonal line below the now point into the past, and we can draw a symmetrical diagonal line, also going through the now point down into the past. These two diagonals will outline two triangles touching the now with their tips. Their bases are open, of course, because we cannot put any limits on the past or the future. In fact, we can visualize the point of now as moving into the future, leaving in its wake many nows, which make up our past. We can also say that the upper, shaded triangle describes the activities that will occur in the future, while the bottom shaded triangle represents the events of the past. The fastest action in the physical world is naturally limited by the speed of light. Therefore, the diagonal lines representing the speed of light set the limits to the speed at which an object can travel within our physical universe. Physicists call this behavior time-like, referring to our normal space-time universe, because all action on this diagram which occurs below the speed of light will tend to cluster around the vertical time axis. In spite of all these apparent limitations, there are courageous physicists who are working on hypothetical particles called tachyons, which can move at speeds higher than light. The speed of tachyons starts just above the speed of light and it ranges all the way to infinite velocities. This brings us to the other portion of our diagram. Suppose that we have a tachyon going at an almost infinite speed, which implies that it is moving practically along the horizontal space axis only. It is going so fast that it uses up almost no time. In the previous example, it took the photon 3 seconds to traverse the 900,000 kilometers as shown in the diagram. The tachyon will travel the distance in practically no time at all, so that we can plot its movement on the horizontal without regard to the vertical time axis. There is nothing to be marked off on the vertical scale since almost no time was used for motion of this tachyon. Suppose now that the tachyon slows down at 1 million kilometers per second. This is still considerably faster than the speed of light, and the point representing the speed of tachyon will naturally be marked off on the vertical line, as shown in the diagram. However, it will appear closer to the horizontal line than to the vertical axis. In short, all speeds that are faster than the speed of light will tend to cluster around the horizontal space axis, and therefore such behavior is called by the physicists space-like. Speeds at which space is traversed while very little time is used up will be termed space-like activity. When something moves so fast that it uses almost no time for its movement, then it moves at an almost infinite speed. And when something is going so fast, then it must be present at all places at once. We mortals could perhaps give this kind of behavior a more fitting name: omnipresence. This is a very important concept on which we shall expand later. Omnipresence. We have all heard about the supersonic planes crossing the Atlantic in an hour and a half. Our astronauts are crossing the Atlantic in about 15 minutes. Suppose now that a plane were developed that could shuttle back and forth between London and New York in half a minute. Imagine yourself asking the stewardess on such a plane as to your whereabouts. She will say, "We have momentarily left New York. We are approaching London. Oops, we are on our way back to New York." Clearly, our question makes no sense. We may just have to accept the fact that we are somehow in both places more or less at once. Now, suppose that we build a vehicle that can travel almost as fast as light. This means that we could go around our planet about 7 times per second. This allows us to see practically any point on our globe within a second. And the people on the earth may see us always at one point or another, so that we are forming a shell of presence on the course around the earth. Let's now visualize that we move at almost infinite speeds. Then it's easy to see that we can go around and through our solar system, or galaxy, or universe for that matter, many times a second, thus weaving a tight pattern throughout that system. We could see everything there is to see and be everywhere in practically no time at all. In other words, we would have become omnipresent. After the novelty of being omnipresent has worn off, and we have become accustomed to the high speeds, we feel that it is insufficient just to whiz around so fast. We would also like to know what goes on in our own solar system. For that, we have to invent a very rapid information processing computer, which we can build cheaply and quickly in our imagination. We can absorb all the information about the solar system as it comes in. We are now not only omnipresent, but omniscient. We find ourselves spreading throughout and around the solar system in a shimmering, vibrating shell, all seeing and all knowing. After all, the difficulties in attaining this great technical feat are forgotten. The attainment of almost infinite speeds becomes commonplace to us. Now we turn inside and begin to contemplate our state, and we arrive at the paradoxical conclusion that going so fast is really the same as being at rest, in all places at once. We come to the conclusion that if we could only expand our consciousness, somehow our observer mind, on the course, could feel all space and would not need to run so fast. Also, we now understand that attaining infinite speed would mean attaining another higher state of rest or state of being. The circle closes here. It is time now to go back to our diagrams. Let's make a diagram similar to figure 23 with the same objective underscore coordinates. By objective coordinates, we mean that they represent space and time as we normally know them. But parallel to these objective coordinates, let's add broken lines representing our subjective coordinates in subjective space and subjective time, as in figure 24. In our normal waking state of consciousness, these two coordinate systems stay parallel and overlap. Most of the time, however, there is a periodic fluctuation which repeats approximately every 1.5 hours. I suggest that during altered states of consciousness, our subjective time space coordinates separate from the objective coordinates and rotate about the common center, as shown in figure 25. Let's rotate the subjective coordinates by an arbitrary angle, which we'll call psi, and draw a line parallel to the horizontal objective space axis through the 1 second mark. This represents the projection of one objective second onto our subjective time. Now let us find on it the intersection with the subjective time, t subscript subject. By measuring the length of the diagonal line from the now onwards to the intersection, we find that our subjective time unit is longer than the objective one. In short, it looks as if we have more time than before to do what we are engaged in doing. In fact, for the angle chosen in the diagram, we have at our disposal 4 subjective seconds to 1 objective second. Let us return to the person under the influence of a mind-affecting drug who is listening to someone speak. Suppose that the speaker utters 1 word per second. The person under the influence of the drug, and presumably in an altered state of consciousness, will have more subjective time to listen to the word and will therefore be in a better position to analyze the word because his mental processes are operating at the normal objective rate. A simple example will provide an analogy for this phenomenon. Suppose that we take a pole with knots on it. When the sun is at a low angle, the shadow of the pole becomes very long, so that we can examine the knots and the spaces between them in more detail. Figure 26. The alert reader will probably remark here, why complicate things so much? Most of these phenomena can be accounted for simply by assuming that our mental processes have speeded up considerably and that therefore the sharpness of our perception has been greatly increased. We don't need subjective time and space to explain time distortions. This, however, is not quite the case, as we shall see later. Looking back at the diagram, we come to realize that any additional increase in psi angle will increase subjective time enormously. As our subjective time axis leans closer to the horizontal, we find that we may have maybe a million subjective seconds to every objective second, because the point of intersection between the horizontal line, marking the 1 second point of objective time, will meet our tilted subjective time axis very far from the now point. And when our subjective time axis becomes finally horizontal, our subjective time becomes infinitely long, so that under these conditions, we are using no objective time at all. At this point, it would be useful to sum up what we have learned from the two space-time diagrams. From figure 23, we know that the faster something moves, the closer it comes to the horizontal line. That is, it exhibits a space-like behavior. From figure 25, we see that the more our subjective time on the course axis leans to the horizontal, the more subjective time we have on hand. If we combine these two diagrams, we have to conclude that a tilting of our subjective time axis causes us to behave in an increasingly space-like manner, which means that in an altered state of consciousness, we are rapidly expanding into space. In other words, an expansion of consciousness leads to an expansion into space. This may occur at speeds below or above that of light. Here, the attentive reader has probably noticed that in our subjective time, we have unceremoniously slipped through the velocity of light barrier. This is something that no physical object can do, but our observer, undercourse, being a non-physical entity, will have no problems doing this. However, the observer, undercourse, is still tenuously linked to the physical body, and the physical senses still relay messages to him in an undistorted form. He still operates, although loosely, against a background of physical spacetime. By crossing the speed of light barrier, he finds himself in a space-like universe. This is a strange new universe in which there is no limit on speed, in which time is being converted into space. The off and on us. It is time now for us to start putting together the assumed bizarre behavior of the pendulum or oscillator discussed in Chapter 3. When the distances per unit time at the extreme point through which the pendulum is moving become extremely small, almost infinite or infinite speeds are encountered. But infinite speeds of what? The answer seems to be infinite speed of a non-physical entity, the observer, undercodes, while the physical body loses its definiteness in space. We cannot know its position. The observer retains its integrity as an information processing unit in spite of its rapid expansion into space. While all we can say about the physical body is that it blinks, undercodes, off and on twice per each oscillation at the points of rest. So as our bodies oscillate up and down about 7 times a second, the observer expands at the end of its movement for an extremely short period of objective time, then contracts, unaware of the event. In other words, our psi angle momentarily opens up and closes again, back and parallel with objective time. This would happen about 14 times a second since we have 2 points of rest per cycle. Normally, we retain no memory of the event. However, the observer can cover long distances within this very short period of time and observe many things. No wonder then that he can be off to a distant beach and be back in a few seconds. As our ability to hold an expanded state of consciousness increases, the psi angle does not close and become zero, but fluctuates at some distance from the objective time axis. This increases our subjective time, so that we can start remembering some information we have received while out of the body. From all the above, it follows that we may describe a person's level of consciousness by the ratio of his subjective time to his objective time. The range of these ratios is very broad. It starts with small differences, which normally would be taken for just a wandering of attention, undercodes, our little experiment with the clock, to hypnotic time dilation, to dreaming, which is clearly an altered state of consciousness, and finally to a deep meditative state in which time is stopped, undercodes, or almost stopped. We can express this in a simple mathematical form. Level of consciousness index equals subjective time over objective time. Or take our example from figure 25. Subjective time equals 4 seconds over objective time equals 1 second equals 4 by 1 equals 4. This is the level of consciousness index. We have not up to this point focused on what is happening to our subjective space coordinate, which rotates together with the subjective time coordinate. As the subjective time stretches, so does the observer, undercodes, expand into his subjective space. Remember, the space coordinate represents three-dimensional space. After tunneling, undercodes, of our time-like to the space-like dimension, our space axis approaches the objective time axis. This carries with it some startling consequences. Our time-like subjective space is becoming objective time. This means that our observer, as he travels in what he considers his space, is actually moving through his own and other people's objective time, either into the past or into the future. This may perhaps explain the mechanism by which clairvoyants operate. They seem to be able to describe the past, some of them surprisingly well. They may even possibly predict the future, but since the future is made up of probabilities dependent on human free will, such travel into the future would be rather vague and unreliable. Figure 27. When one asks a clairvoyant how he does his thing, undercourse, he answers, "I'm going into your past." He has a feeling of moving through time. Time is space for him. Let us return to our experiment with the clock. I've asked you to visualize a favorite activity. This automatically programmed your observer, undercodes, to move into the past because your favorite activity can only be an experience of the past. Your observer moved into the past and was off to a beach in a wink and back in another wink. He went in his subjective time and space into a different reality. One can consider projecting one's observer into the future, but this is not too strenuous. Again, time will slow down. All this sounds very confusing at first. However, it's a rather simple and compact way of explaining many puzzling phenomena to which there are as yet no scientific explanations. What, then, does reality consist of? How do we see reality in the light of all this? Our solid and not so solid realities. Let's go back to the pendulum, which is our body. It oscillates up and down about 7 times a second. Each time the body comes to a rest, 14 times a second, the observer expands at a very high speed through this subjective time into objective space. This expansion takes practically no time. Figure 28 describes the relationship between our different realities. Our solid physical reality goes on as usual, except for tiny pauses, during which our observer takes off and comes back. During the out periods, undercodes, in the other dimensions or realities, an untrained observer comes back without communicating any knowledge of this outing to the mind and the brain. In other words, this experience does not normally reach the conscious thinking level. A very good example of this is so-called subliminal advertising, undercodes. This was a technique used some years ago by which products were advertised in the movie theaters or on television by flashing for a very short time a message on the screen. The public was never aware of what was happening since the message was too short to activate the conscious mind into producing a coherent thought image. But the subconscious mind, being much quicker, did pick up the message, and people dutifully consumed the advertised products. These techniques have fortunately since been outlawed. A trained observer, the one who can stay at high level of consciousness for a while, has, as shown before, managed to stretch his subjective time considerably. Naturally, he may be able to observe and be imprinted with the information he sees. Then, upon his return, he may formulate the imprinted visions into thoughts. While one is in an expanded state of consciousness, his reality diagram differs from that of figure 28 and looks rather like figure 29. If you notice the top line, his other reality has become as continuous and stretched out as his physical reality. He is spending as much time there as on the physical level, not in actual objective time. He should therefore be able to make a coherent picture of his experiences and describe what he sees there. The development of the ability to retain the information will be explained in the coming chapters. We have until now used the 7 Hz rate of motion of the body as a trigger for the ejection undercourse of the observer. But as you may remember from chapter 3, any oscillator will tend to disappear and reappear at its own rate. The atoms of our bodies are such oscillators. They vibrate at a rate of about 10 to the power 15 Hz. It is possible that our bodies blink on and off at this very high rate. There is no way of knowing whether this is so, since presently we have no way of registering such a rapid phenomena. However, we cannot assume that all the atoms in our bodies beat synchronously or coherently. We have to visualize our bodies blinking on and off gradually, different areas disappearing, others appearing. In other words, we are partially out all the time. This does not, however, alter the basic model presented here, since it does not matter how long the on and off periods are. In the unlikely event that total coherency occurs in the body, this may occur at very high levels of consciousness, then naturally the whole body will blink off and on as a unit, and we may expect to see some very unusual things occurring in such a state. We took the 7 Hz pulsation as the minimum number of on and off periods, since that is a measurable figure. Summary. An experiment with time shows that we have objective and subjective spacetime which normally coincide. Under altered states of consciousness, these two become separated and we can function in our subjective spacetime. This explains many phenomena such as clairvoyance, telepathy, etc. We postulate an observer, which is our psyche, and which becomes omnipresent, undercourse, for a very short period of time. This is the time required for the pendulum or oscillator to change its direction of motion. Our bodies are oscillators, and the atoms making up our bodies are also oscillators. Therefore, we expand into a space-like dimension many times a second very rapidly and collapse back as rapidly, possibly at the rate of atomic vibration. However, in an altered state of consciousness, we can expand our subjective time greatly. This allows us to observe the action of other psyches that are out there, undercourse, at a leisurely pace and bring back useful information from there, undercourse. This is done without using up much objective time. So our reality is made up of a constant rapid back and forth shuttling between our solid reality and the way out realities which we share with everybody else. An expanded or higher state of consciousness implies an expansion of our psyche into space,